All right, so let's take a quick look on the unit circle. Now, to make your unit circle drawing, writing a lot easier and a lot more enjoyable, you really want to make sure that you can discover all the patterns. Now, and how can you observe all the patterns? So the first thing that I would advise you to do is to first write down where it is 1/2. 1/2 is pretty easy to tell, right? And not just 1/2, also write down -1/2. Okay, on both x and y axes. 1/2 and -1/2. And once you do that, you can at least get some coordinates filled out. And that's very important because I want you to think about the unit circle as a growing network. Okay, I want you to think about the unit circle as a series of numbers that can grow in size. For example, among P, Q, and R, which one has an x value of 1/2? All right, so we say, oh yeah, PQR, it is 1/2. And by the way, did you realize that all the values, like in the middle of the quadrant, they're all over 2? Did you realize that? Okay, they're all over 2. And then, if this is 1/2, what will be the other 2 values? It's always √2/2 and then √3/2. So if you know where 1/2 is, you know the other 2 x coordinates. And if you know the x coordinates, you know the y coordinates because they will be the same when it is √2/2. And if it's 1/2 of the x, it must be √3/2 for the y. If it's √3/2 for the x, it must be 1/2 for the y. Okay. And then you do the same thing on the other side. Okay. You do the same thing on the other side. So for this point, it'll be -1/2. And then you just go ahead and fill out the rest. Now, I don't want to focus too much on the coordinates because once you know the trick, it's easy to fill out all the blanks. Now, what I want to spend time on for the next minute or two is to help you understand the labeling of angles in radians because radians may not be something that you're comfortable with. Now, can you look at the red line right here on the picture? The red line. Now, the red line, it's right in the middle of the quadrant. In the middle of each quadrant. And if you look at that, can you tell? Can you see how they're all the same? It is all with the denominator of 4. It's all with the denominator of 4. And then I want you to look at the smaller reference angle. How do we measure reference angle? From the x-axis. So I want to look at the smaller reference angle, which is the green line. Look at the green line right here. Can you see anything in common with all the angles that's close to the x-axis? The denominators are all Did you realize that? That's all. It's the angle that's close to the x-axis is all over 6, and the one that's farthest away from the x-axis is all over 3. Well, the reason is the reference angle right here. It's for the green one. The reference angle is pi over 6. For the red one, it is pi over 4. And for the blue one, the reference angle is pi over 3. That's the reason of the denominator being 6, 4, and 3 respectively. And then you want to get the numerator correctly. And you look at quadrant 2. Can you look at quadrant 2? Look at the number in the numerator and compare it with the denominator. Can you see something special? It's always what? The number in front of pi, it's always 1 less the denominator. You have 2 pi over 3. You have 3 pi over 4. You have 5 pi over 6. It's always 1 less than the denominator. And there's a reason behind it, because we actually use the reference angle to do the calculation. Like 5 pi over 6 is because of pi minus pi over 6. That's a reference angle right here. And then when you do the subtraction, 6 pi over 6 minus pi over 6, that's how you get 5 pi over 6. And then you look at the quadrant 3 angle. Anything special when you look at the quadrant 3 angles in radians? What's the number in numerator? It's always 1 higher than the denominator. So you have 7 pi over 6. You have 5 pi over 6. And you have 4 pi over 6. Oh, no, sorry, 4 pi over 3. 4 pi over 3. And what about the quadrants in the fourth quadrant? What about the angles? Can you describe the numerator? One less than double. So that's why the numerator for the over 3 will be 5 pi over 3, because it is 1 less than 6. So for the red one, it will be 1 less than 8. For the green one right here, it will be 1 less than 12. Once you start seeing these patterns, it's easy. And that's how I say you can do it in 5 minutes. I give you 10 minutes, you start handing in 5 minutes. 100 next Monday? Get 100 next Monday? Okay. So, yeah, make sure you do that. And now what we are trying to do today and tomorrow is this. So for the past few days, Monday and Tuesday, we used the calculators, and I made a huge emphasis that you must know the difference between angles and ratio of sides. So what we're doing right now is basically, I give you the angle, please give me the ratio. Or I give you the ratio, please give me the angle. It's really this kind of a drill. So, but with unit circle, things could get a little bit easier. So if you think about the unit circle, remember that cosine theta is, cosine theta, it's adjacent over hypotenuse. But in unit circle, adjacent side is the x, and the hypotenuse is 1. So we'll just say, oh, x is equal to cosine theta. The x value is the cosine theta. The y value is the sine theta. And don't forget the very first day that I told you that tangent theta, it's equal to sine theta over cosine theta, okay? Tangent theta is sine theta over cosine theta, and that's the reason why tangent theta is y over x. Or you can also think about it is just the opposite of adjacent, so y over x. Again, okay? So, and then we have, of course, the other side, we have secant, cosecant, and cotangent. It's just the reciprocal, okay? Secant is 1 over cosine, so 1 over x. Cosecant is 1 over sine theta, so 1 over y. And cotangent, it's the adjacent over the opposite, so x over y. Okay. So now let's look at the back page. Okay, and see if you can get the values without looking at the unit circle. So you look at this cosine of pi over 6. What's the ratio? So what we're asking here is this. If the angle is pi over 6, what is the ratio? What's the ratio of adjacent over hypotenuse? Or, referring to the unit circle, what's the x value when the angle is pi over 6? Root 3 over 2. And that's it. So our goal today is to make sure that you are developing your fluency in capturing the values. Okay, is it positive? Is it negative? Is it 1? Is it 0? Is it negative 1? Is it root 3 over 2, root 2 over 2, 1/2? All right, so that's the x value at the angle of pi over 6. And then we say, hey, what about the y value? 1/2. Okay. And we say, hey, what about the y value over the x value? We say, oh, it's 1 over root 3. And you have to rationalize it, so it becomes root 3 over 3. Okay. Any question for question 1, 2, and 3? Good. And now, what about cotangent? You can say, oh, cotangent. You can think about this as, oh, that's just x over y, which is root 3 over 1. Or you can think about this as 1 over the tangent of pi over 6. So you get pi over 6, and then you just do the reciprocal. You can think of this either way. As long as it's correct, that's good. And secant, it's 1 over cosine. So I have 2 over root 3, 2 over root 3, and then I need to rationalize it. And I got 2 root 3 over 3. And then cosecant of pi over 2, pi over 6 is just 2. Okay. So I'm going to give you 5 minutes to 5 minutes to work on this, all the way to 17. Okay, and then we can check answers together. I think you can handle this. Now I would advise you to try to see if you can get the values without the help of the unit circle on the front page. And then if you say I can't, then you go ahead and look at it. But give yourself a shot. Tell if you could get the values without any assistance. Okay, so 5 minutes. Go ahead, 5 minutes. All right, let's check some answers. Now, let me give you a little expectation for these questions. How much time you should spend on each question? To be generous, I would say 5 seconds. For each question, 5 seconds, top. To be superb, like straight A student, 2 seconds. Okay, so I'm just giving you the expectation so that you know where you are. Now, at the end of the class, I'll teach you something too. It's exclusive in this classroom because this is actually not the way I learned trigonometry. So I will share my way of learning with you and see which one you like better. Okay, I don't really care which way you do. as long as you give me the right numbers. So tangent 0 is 0. Cotangent 0 is undefined. Tangent pi over 2 it's also undefined. Now do not write no solution. No solution is no solution. Undefined is undefined. They're two different things. Cosine of 30, root 3 over 2. Sine of 135, root 2 over 2. Tangent 240, square root 3. Okay, so now I don't, by the way, I don't have an answer key with me. I'm not copying. It's really real time in my head. Sine of 11 pi over 6, negative 1/2. Tangent of 2 pi over 3 is negative root 3. Secant of 5 pi over 4. So the way I look at this would be 1 over cosine of 5 pi over 4. So I'm like, what's cosine of 5 pi over 4? That would be root 2 over 2. So reciprocal of that would be 2 over root 2. And that is just root 2 after you rationalize it. Okay. Now for questions 16 and 17, I was strong, I demand you that you use a pair of parentheses for each thing. Now we have two trig functions multiplying together. So to really help you live a better life, use parentheses. And then you just put in each individual ratios into these parentheses. Cosine of 7 pi over 6 is negative root 3 over 2. And sine of 3 pi over 4, it's root 2 over 2. And then just go ahead and multiply. You have negative of root 6 over 4. Can we simplify these two numbers? They look tempting. And if you are tempted, then make sure you write a note next to it. You cannot simplify these two numbers because the 6 is inside the or underneath the square root. So if you felt like you're tempted, you could be tempted, write down a little annotation next to it. Okay, they cannot be simplified. And then you look at this. Cotangent of pi over 3 is negative 1 over root 3. And then secant of pi, it's negative 1. So you have 1 over root 3, and then you have root 3 over 3 as the answer. Now, tomorrow's work, it's more like question 16 and 17. So today, you really want to have a good idea how to get the values. Okay, you really want to know how to get the values. Now, what about 18 and 19? What are we talking about here? So question 18 is like this. It tells you that, now, as I said earlier, the whole game is like this. We give you the angle, please give me the ratio. Or we give you the ratio, please tell me the angle. So we are like, hey guys, the ratio is negative 1/2. What is the angle? What is the angle here? So we basically is also saying that if x value is equal to negative 1/2 on your unit circle, if x value is equal to negative 1/2, what are the angles? If x it's equal to negative 1/2, What are the angles? Can you look at your unit circle and tell? What are the angles? It'll be x being negative 1/2, 120 degrees, and 240. Okay. And in radians, we will say it is 2 pi over 3 and 4 pi over 3. Okay. Now, if you look at the bottom one, the bottom one is cosecant theta. What's cosecant again? 1 over sine, right? So now, and do you remember what I said about secant and cosecant? My opinion, I do not like them. So if I ever see them, I would convert it back to sine, cosine, or tangent. So cosecant, it's the reciprocal of sine. So to change it back to sine, just go ahead and reciprocate both sides. You can go ahead and reciprocate both sides and say, hey, if x is equal to 1/2, if x is equal to 1/2, what are the angles? No, sorry, my bad. If the y is 1/2, sine theta is the y value. So if the y is equal to 1/2, what are the angles? 30 degrees and 150, right? So in radians, it's pi over 6 and 5 pi over 6. Do you understand the game now? The game is we give you the angle, you give me the ratio. Or I give you the ratio, you give me the angle. Thank you. All right, now, so you can see the if you look at the handout, okay, the front page, that's something that will stay with you for a good long time. So you really want to practice this very well. Now, at this moment, if you want to be entertained, you can go ahead and draw the following table. And this is how I learned about these trig functions without the unit circle. And you can see which one you like more. Okay, you can see which one you like more. So a good place to draw this table on the back page, second page of the handout. There's a little empty space right there. You can go ahead and draw this table. Okay. Now, I really like this method because I think unit circle, it's good in terms of justifying the values. But if you have to memorize the whole thing, it takes a bit of time. And I think it's quite hectic. It's quite demanding to get all these values firmly retained in my head. So I really like this table. I've been using this for over 2 decades. So it's very well tested. And I use this table to get the values. And basically, I can get all the values within 2 seconds. And that's why for the past few days, I've been asking you every single day. There are 4 quadrants. What are the 4 quadrants? A, and then S, T, C, right? So I've been bugging you with all these quadrant stuff. And I also made a huge emphasis on how do you tell the quadrants, the angles. Is it quadrant 1, quadrant 2, quadrant 3, or quadrant 4? Making sure that you can tell them very quickly, very easily. So we will shift our focus on just the quadrant 1 angle, just the quadrant 1. And if you know these values, you are good. You are good. And since you have done your unit circle, the values that you see here, they are going to be very familiar. Now, my claim is this. You can actually memorize this whole table within 5 minutes. But for the unit circle, it may take you about a few days. Now, the reason why you can get this table done so quickly is because once you know the first row, you know the rest of it. You know the rest of the table. Now, it's very easy to retain the values. First, for sine theta, it goes from 0 to 1. It goes from 0 to 1. Okay? And if it goes from 0 to 1, what do we call this order? Is it ascending or descending? Ascending, right? So since it's ascending, well, for the middle 3 boxes, well, they're the fractions. And they are all fractions over 2. As you have seen from the earlier unit circle values, they're all over 2. And since it is ascending, well, guess what? We will put down 1, 2, and 3. Don't forget, they have to wear a hat. And we don't put a hat onto the 1 because square root of 1 is 1. So just leave it. So my point here is this. If we are memorizing something, I want to make sure that you memorize the least amount of things and still produce the most accurate results. And if you get the first row done, oh, the second row it's also done. Because it starts from 1 and then 2, 0. And guess what about the fractions? Descending. So that's why you put down 3, 2, 1. Oh. Can you see how if you know the first row, you know the second row? It's just reversing the order. And if you know the first 2 rows, and remember what I said about tangent? Tangent is sine theta over cosine theta. So it's just basically doing the first row divided by the second row. 0 over 1, 0. 1/2 over root 3 over 2. 1 over root 3. I will keep it like this for the moment. I know I need to rationalize this, but I will keep it like this because it helps my memory. Same number dividing each other. 1. Root 3 over 2 over 1 over 2. That's root 3. And last one, 1 over 0. Undefined. Now, as you're memorizing these tables, if you choose this method, I will also tell you this. as you're memorizing, some values are a lot easier to memorize. The ones and zeros. Just make sure you know where it starts and where it ends. And there are some other special easy numbers that would be very easy to keep in your mind. The 1/2. And also the one right here. They're easy to remember. Just make sure you know the relative locations. And then another one, another value that's also easy to know is the √2/2. They're right at the center. And they are the same for both columns. I think that's pretty special. So once you know these values, you can pretty much fill out the remaining blanks. But now, this method only, this table only covers the first quadrant. What about the quadrant 2, quadrant 3, quadrant 4? Well, that's why we need something more, which you had already. So next to it, you can write this down. When we do all these problems, the first thing that we need to consider is the sign of the trig function. And this is told by the quadrant. Remember A, S, T, C? If you know the quadrant, you know the sign. And number 2, why do we only know these angles? Well, these are not just the angles in the first quadrants, these are actually the reference angle. Can you tell the reference angle? It's very easy to tell, by the way, because if I tell you something like, 5π/4, what's the reference angle? π/4. And you can tell the reference angle very quickly because you can look at the denominator. If you can see the denominator, 5π/4, what's the reference angle? π/4. Now let me give you a few practice to see how this is being used in real time. And I'm going to use this number 4. Okay, number 4 on the worksheet. So first one, I look at the quadrant. What quadrant is this angle? Quadrant 4, and it's sign, that means it must be negative. And then what's the reference angle? π/3. So basically we are thinking about negative of sine π/3. And you look at the table, okay, for the moment, since you don't have it memorized. So you look at the table. What's sine π/3? √3/2. Done. Done. Now let's look at number 6. Tangent of 225. What quadrant is this? Quadrant 3. And tangent in quadrant 3 is positive, so we're good. And what's the reference angle for 225? (45°). So tangent 45, it's 1. Now, you don't have to write this. I'm just writing this so that you know how we make use of the reference angle. Okay, how we make use of the reference angle. Let me select one more. Let's just say number 10. Take a look at number 10. So we are like cosine of 5π/6. What quadrant is 5π/6? Is in quadrant 2. And cosine is negative. So this would be the same thing as negative cosine of π/6, which is negative √3/2. So if you have the table, in your mind, that will allow you to refer to the values in much simpler way. So that's what I've been using for decades, and that works very well. Okay. So the option is yours. Okay. Now you have two methods. Your goal, your task is that can you extract these values in less than 5 seconds for each question. You have to make it happen. You can choose the how, but you have to make it happen. 5 seconds each. Okay. If it takes you more than 5 seconds each, that means you are putting yourself at a risky position. Very risky. Now, what about these? How about these guys? Okay, like for example, what about cosine theta of pi? Cosine theta is equal to √3/2. So I'm thinking about, wait, hold on, it's positive. Cosine of what quadrant? It's positive. Quadrant 4 and quadrant 1. And I'm looking at √3/2. I'll be like, wait, hold on. If I'm looking at the table, what angle would give you √3/2 for cosine? Pi over 6. Oh, if it's in degrees, then we do 30 degrees. So what's the angle in quadrant 1? If the reference angle is 30 degrees? 30. What's the angle in quadrant 4 if the reference angle is 30 degrees? 330. Done. So this method, again, it doesn't require you to go for the graphical accuracy. It's just the arrangement of numbers. So make a decision. Make a decision of which one you prefer and stick with it.